This is the second in a series of 5 videos on finance. Today we'll do present value, which really only amounts to rearranging the formula we developed in the first video, the compound interest formula. If it's true that A equals P times 1 plus I to the exponent n, then it must be true that if we write it backwards, that's also the same thing. And what we intend to do with this is isolate P. So we'll take that factor right here and divide it over and underneath that A. And we also know that when there's a factor in the denominator raised to an exponent, we can boost it up, so to speak, and make the exponent negative. So this must also be true. So the present value formula is in the box here. And it's only a rearrangement of the compound interest formula. It gives us the size of the investment required to reach a target amount. So it will be always a little less than the target amount because the required investment is going to be maturing as it sits in the bank earning interest. So to answer the question, how much must be invested now? Whenever we see that question, we'll use the present value formula. The amount that must be invested now is P. P equals A, the amount, times 1 plus I to the exponent negative n. Example, how much money must Ruprecht invest now in order to have $15,000 for college in 5 years' time if money earns interest at the rate of 7% compounded monthly? So we see the first sentence, how much money must be invested now. We know we're going to need the present value formula. And then we treat this formula the same way we treated the compound interest formula. Figure out P, A, I, and N. $15,000 is the target amount, so that will be the amount after time has passed. Ruprecht wants to have $15,000 for college 5 years from now, so A must be $15,000. Money is earning interest at 7% compounded monthly, so the I value will be 0.07 divided by 12, which the calculator tells us is 0.00583 repeated. And N we can also figure out using our skills in 5 years' time compounded monthly. So how many months go by in 5 years? Well, it'll be 5 times 12. And so N is 60. And so our intention is to plug them all in and use our calculator. Plug them all into the present value formula, use your calculator, and we get a present value of $10,581.08. What this means is that if one were to invest this amount, it would mature to $15,000 in 5 years. This is the present value of $15,000. Notice how it's less. He needs to invest $10,581 now. Let's do another example. How much must be invested now to realize a $75,000 down payment on a house in 5 years' time if money earns interest at 6% compounded quarterly? So we see the question in front of us, how much must be invested now? And we automatically write the present value formula. Then we'll need the P, the A, the I, and the negative N. So the amount is after time has passed. This A is after time has passed. $75,000 in 5 years. So after 5 years has gone by, we want our investment to become worth $75,000. So A is worth $75,000. Next, we could figure out N. We know that N is going to be equal to, well, if we reason this, it's compounded quarterly for 5 years. Something happens 4 times a year for 5 years. So we can get N this way. 5 times 4, 5 years, 4 times a year, it's 20. Meanwhile, I is calculated in the familiar way. I is equal to the interest rate as a decimal divided by the number of compounding periods in a year. So I will be 0.06, because that's 6%, divided by 4. And so I is 0.015. Plug them all in, take your calculator, and don't take my word for it. Find out that yes, $55,685.28 must be invested now. It's the present value of $75,000. Notice how it's less. Because it will mature to $75,000. Example 3. How long will it take $5,000 to double if money earns 8% a year compounded quarterly? Well, this one doesn't ask the question how much must be invested now. It asks how long will something take? So we can just use the compound interest formula and plug in. Now we note that $5,000 now is going to double. So P will be 5,000 and A will turn into double that, 10,000. Money is earning interest at 8% compounded quarterly, so I will be 0.08 divided by 4. That'll be 1.02 in here to an unknown N. Divide both sides by 5,000, and in this configuration, N equals log over log 35. 35 quarters, 35 interest periods. To find out how many years, divide by 4, and we get 8.75. So 8 3/4 years.